Two objects each of mass 1.5 kg are moving in the same straight line but in opposite directions. The velocity of each object is 2.5 meter per second before the collision, during which they stick together. What will be the velocity of the combined object after collision? So in the given problem, two objects are given. So I am having here, so this is the green ball you consider. So this is one of the object, and the velvet ball, so this is another object. So they are moving in opposite directions and their mass is also given. Mass each one equal to 1.5 kg. So if I take this ball as m1 equal to 1.5 kg and this is m2 is equal to 1.5 kg, and they both are moving in opposite direction. So suppose if it is moving in this direction and another ball that is moving in opposite direction, and they're given their velocities also. If I take this ball velocity as v1 which is equal to 2.5 meter per second, and this I'll consider as v2 equal to 2.5 meter per second. But velocity is a vector, so if its direction changes, we need to that mention as a sign. So here I am taking this as a negative sign, or you take like this. Suppose if you take coordinate axis, so this is x and y axis. If an object is moving along positive x-axis, so this we will take that as positive. So this is positive x-axis, just like green ball is moving along in this positive x-axis direction. But another ball which is moving in opposite, it is moving in negative x-axis direction. So that's why this ball velocity we should take as negative. So this is very, very important. So this is the situation before collision. So before collision, they are having their mass and velocity. Now after collision, what happens? So it means they both are collide. Suppose if I take this image, I will take the ball and this one I will copy. Yeah, now these two are collided. Now this is situation after collision. After collision, they both are stick together, and they both are stick together and they both are moving together. They both are stuck together and moving together. So after collision, so their masses, they do not change. So mass m1 equal to 1.5 kg for this green ball, and this mass m2, this is also 1.5 kg, but their velocity changes. So after collision, the velocity changes. We need to find how much is this velocity. So that is our task, find the velocity. So to find the velocity, we will use the law of conservation of momentum. So we are having a formula: momentum, total momentum before collision equal to total momentum after collision. Now if I can write that in terms of formula, I have taken m1 v1 plus m2 v2 is equal to m1 v plus m2 v. So here remember why I have taken this as v. So v is the total final velocity with which the object is moving. So that's why their common velocity we have taken that as v. m1 also having v as velocity and m2 is also having v as velocity. Now let us substitute the values which is given there. Now if you can substitute those values, m1 1.5 times v1, that is 2.5, plus m2 value is also 1.5 and v2 minus 2.5 is equal to m1 1.5 times v plus m2 1.5 times v. So if I do this calculation, so we can multiply this. Before multiply, if you can see commonly, so these both values are equal and minus. So if you can multiply 1.5 times 2.5, so that value goes to me 3.75. Let me check with the calculator. So here I can get that 3.75 with negative and 3.75 is equal to, I have taken it here 1.5 as common, so I can get that v plus v. So here equal to 0 is equal to 1.5 times 2 times v. So finally we can write that everything times 0 equal to 3 times v. Therefore we need to find final velocity v equal to 0 upon 3, which is equal to 0. So what this sentence says, the final velocity after collision equal to 0. So that I can write it here. Therefore the final velocity after collision is 0. So it means they don't move at all, so they will be there. Let's see one more problem. A hockey ball of mass 200 grams traveling at 10 meter per second is struck by a hockey stick so as to return it along its original path with a velocity at 5 meter per second. Calculate the change in momentum occurred in the motion of the hockey ball by the force applied by the hockey stick. So they're given that a hockey ball, so here I'm having hockey ball, so its mass equal to 200 grams. So we will write that in terms of kg. Therefore mass of hockey ball equal to 0.2 kg, and this hockey ball is moving and striking hockey stick. So here it is hockey stick. Now after this ball is moving and hitting the hockey stick, now after hitting that one, what happens? The ball will be returns. Okay, so if I can take this as one more, so this is hitting So after hitting the hockey stick, again the ball is moving back. So it will go all the way from here and it will be strike the bat and it is come back. So now, so this is the situation after hitting. After hitting hockey bat. So before hitting hockey bat, the ball is moving with velocity. This I can take as 10 meter per second. So after hitting, the ball mass, it do not change. It's 0.2 kg only. But what has changed? The change in velocity, they are given that 5 meter per second. So to remove the confusion, here you take this initial as velocity v1 and after hitting this take as velocity v2. And here you remember, after hitting the ball is coming back. So if it is coming back, so it is moving along in this direction. So this is after hitting. So before that the ball is moving in this direction. This is before hitting. Now if you remember, when object is moving backwards, we need to take that as negative sign. So here I need to take that as negative sign. So this is very important point. After hitting the bat, the ball is moving back into the same path. So that's why here we need to represent the velocity as v2. Now we need to calculate the change in momentum. What the formula you can write? Change in momentum equal to initial momentum minus final momentum. Change in momentum equal to final momentum minus initial momentum, or initial momentum minus final momentum.